Hello, I'm back. And what we're going to go over is the second page of this. This is on conductors versus insulators. Conductors of electricity also conduct heat and thermal energy. Electrical wires have a metal center to conduct electricity surrounded by insulation for protection. The middle part is your conductor, and then the insulator is the part that's wrapped around it, much like the wires we used when we were wiring our houses in class, where you cut and stripped the yellow wire and then you added it to the different ends of the battery ends and then formed your switches and so forth. So conductors allow electricity to flow, or electrons to flow. Metals tend to be excellent conductors. Insulators resist the flow of electricity. Conductors tend to be light or have air holes. Conductors tend to feel cold because they accept your heat easier. Pour water is a poor conductor, good for drinking, not so good for heat conduction. Sports drinks add salts, and salt water is a very good thermal conductor. I remember when we were doing the snap circuits, I think it was Valentina and Cheyenne. Cheyenne added salt to a bit of water and they were little like anodes into the water, and there was a speaker attached and it created a sound, versus water with no salt had a different sound, and then you added water with salt, the sound got higher and changed pitch and so forth. So that was pretty interesting to see how it became different sounding, and that was actually probably based on the conduction of the water itself. If we go down here, what you had to do, and I already did this before and I recorded it and somehow I deleted it, so I'm not going to start all over, but you can just see how we got the answers. You had to match up the correct word with its definition. I honestly always start with the definition and then connect it to the right word. So the first one is the charge that attracts protons, and that is a negative charge. And then you have B, an atom with a different number of electrons than protons. That is called an ion because it's not neutral. And then you have a material that resists the flow of electricity. That's an insulator. So that's why all wires have insulators on them, so that the flow of electrons will just go through exactly where they want it to go through the wire, nothing else. And then caused by the flow of electrons, that is speaking about electricity itself, which is by definition the flow of electrons. Then we have the charge that attracts electrons. That would be a positive charge because opposites attract. And then we also have the last one, a material that does not resist electricity, and that is a conductor. They help electrons flow. Electrons flow through them. So that's why they're called conductors, because they conduct electrons toward wherever they're going, wherever they lead to, like wires. Next side, you're matching again the definition to the word. A unit in measuring the amount of charge, we call this the coulomb. It's totally a man-made unit of measure, but it was like Coulomb was this guy, his last name was Coulomb, and he figured out how he could measure the amount of charge in an object, and that is how he came up with the unit and the measuring device that he used. The pushes and pulls that electric charges exert on each other, electrical force. I know that because push or a pull is a force, and so that was kind of a giveaway to me, and may have been familiar to you because you studied pushes and pulls and forces last year in 8th grade, I believe, and then definitely in elementary as well. My daughter's in 4th grade and they're like going over Newton's laws, so it's just really interesting how you keep seeing the same topics over and over again, and hopefully they're becoming a little more difficult as you go through the years. If they're not, ask for more. An object that has equal amounts of positive and negative charges, that's a neutral object, and that is electrically neutral. So if same number of protons, same electrons, it's neutral, it's an atom of something, it's not an ion. And then finally, E, a buildup of charge on an object, that is number 1, or an electric charge. So please make sure you study these because I'll have them somehow on the test. What are the charges of the second object? So basically all you had to do is to fill in the right charge. If they attract, if these guys are attracting one another, then they must be opposite charges. So this is negative, this is positive. If they repel against one another and they already give us a positive, then this has to be a positive because like charges repel. An atom that loses electrons becomes positive because now it has more protons, which are more positive, and we call it a cation. And then an atom that gains electrons becomes more negative, and we call that an anion. And then it says, what is the charge of an atom with 12 electrons and 10 protons? That is, it has a -2 charge because it's basically 10 minus 2, which is -2. The positive, or it's P minus E. That's the order that it goes in. P minus E equals blank. And I could actually write that. P minus E equals, and this is your number of, or your charge. What's the element? This one happens to be neon. Of course, you may not know it off the top of your head, but if it has 10 protons, that identifies the atom it is. You go to the periodic table, you look for number 10, and it will tell you that it's Ne, or neon. And it is an anion, which is not underlined yet because it has a negative charge, 2 negative. So it would actually look like this. Ne with a 2 negative. That's what it would look like. And we're going to be doing some of this next unit where we look at the periodic table and then charges of each and why and how they form compounds together. Next one, we have 8 protons. We don't care about the neutrons right here, but these are the electrons, so we have to count them. This particular one has 1, 2, 3, 4, 5, 6, 7, 8 electrons plus 2 in the middle is 10. So this one actually has a net charge of -2. And this is an ion, and it would look like this, 0 to negative. That would be the symbol of it. And interestingly enough, right here, they're showing where those other 2 negative electrons may have come from. They could come from a lithium atom, and this is a lithium atom right here. How do we know that? Because if it has 3 protons, it's lithium, which happens to be number 3 on the periodic table. So here we go. So if you were to look at it as kind of an atomic structure, you would have your, that is not a good circle. You would have 2 lithiums, which are the smaller ones, and then they would form a bond like here and then here. This would be your neon. This is not a very good drawing. Neon, and then this would be your lithium. And see, so if they lost their electron, they gave it to neon. So you have 2 lithiums that lost an electron, gave it to neon, and now they're paired up, and they're both satisfied with their outer shell configurations. But don't worry about that because we're going to do that next time. So down here we have protons, number 3. That means it's lithium. You have to go to the periodic table to look it up for number 3, which also identifies the number of protons and the number of electrons it normally has. This one says it only has 2. That means it lost 1. So it has a net charge of +1 because it has 1 more proton than electron. So we call it an ion because it's positive. It's a cation specifically. And so the ion notation would be Li1+. And what would happen if these 2 atoms were brought close together? They would be attracted to one another and form an ionic bond. And it's called lithium oxide, or its chemical formula would be Li2O. And there's no 1 over here because you don't show the 1, but it would be 1 atom of oxygen and then 2 atoms of lithium. Okay, So go back, look through all that, study it, and we're done with that page.